it gives you a general idea of where you're starting from and where you're going to. So that's why when we take, for example, the nigrostriatal is going to start in the substantia nigra pars compacta. The only reason I highlight this is because there are two major parts to the substantia nigra, and it is the compact part, the compacta, that actually has the large number of dopaminergic neurons. This is also, as you may remember, you've probably heard this many times by now, that this is why the substantia nigra has the color that it does, is because when tyrosine is converted to dopamine, one of the other products that's accumulated is melanin, and so then that's what gives it its color inside of these neurons, and then that's how they first recognized it and named it, was due to the fact that it has this black strip appearance. The function of it wasn't specifically listed in your lab, so that's why I'm not going to talk about the function of it. So when you see this, it's because the lab itself didn't expressly say what it is, and I'm not going to give you extraneous information. Next pathway we're going to talk about is the mesocortical limbic. Okay? And these two together are known as the mesencephalic pathway. So if you do see this term, don't panic. It's just when you combine these two together, that's what it's known as. Okay, so the mesocortical limbic, our main nucleus of interest is going to be in the ventral tegmental area. And so if you remember, the tegmentum is within your midbrain, so this is just simply telling you the relative area within the midbrain that you would find this. And it's the one that's most related towards reward addiction and what they sometimes refer to in psychology as motivation. This is sort of like what drives you to engage in sort of impulsive and addictive behaviors. And then the final one we're going to talk about within the dopaminergic pathway is the tuberoinfundibular. And this, as it says in the name, you see infundibular, so it's related to the hypothalamus. So this is actually starts in one of the nuclei of the hypothalamus, the arcuate nucleus. And what it does is it acts upon the pituitary axis. And so this is what actually inhibits prolactin release from the pituitary. So when you talk, you may have heard before that dopamine, another name for it, is prolactin inhibiting factor. This is largely where they came up with that name, is because they recognized that dopamine was capable of inhibiting the release of prolactin. So those are all of our dopaminergic pathways. Now we talk about our